Okay, this is a short video that we've put together to explain the diffusion of innovations. My name is Tom Valente. I'm a professor here at the Keck School of Medicine, the Institute for Prevention Research and Department of Preventive Medicine, University of Southern California. My email address is there. If you have any questions, you're free to email me and I'll try to answer your questions as best I can. So, diffusion of innovations is an exciting area of scientific investigation being applied to many different areas of research, and I want to provide a short introduction to some of the basic principles. Diffusion is the spread of new ideas and practices within and between communities. And not surprisingly, understanding how ideas and practices spread is something of interest to many scientists, scholars, and practitioners across many different domains and area of research. One important principle of diffusion of innovations is that it takes time. Typically a long time from the very first adopters to the latest adopters for any new idea or technology. And there are many societal, individual, cultural, technological, and other factors that influence the speed and character of diffusion of innovation. So many things affect how something diffuses, how quickly and to whom. The classic study in the diffusion field was conducted back in the early 1940s, published in 1943 by Bryce Ryan and Neil Gross. They studied the diffusion of hybrid seed corn among farmers in two communities in Iowa. Hybrid seeds were being developed in the early part of the 20th century up until about the late 1920s, and then once these hybrid seeds were developed in many different areas across the country, it took a while for seed companies to be created and get farmers to adopt the purchase of hybrid seeds rather than replanting their old seeds from the last year. So diffusion of hybrid seeds was a very important phenomenon that occurred early in the 1940s and 50s throughout the United States and then internationally. You can see from this graph that Ryan and Gross made that there were few farmers that adopted hybrid seed early in the 1930s. Eventually the process took off until virtually all of the farmers in those two communities were using hybrid seed over a period of about 14 years. You can also see that there is a new adopters curve or an incidence curve which indicates the number of new adopters of hybrid seed at each year, and it follows something close to a normal distribution. This publication established a paradigm for which are the important variables to study and investigate when trying to understand the diffusion of a new technology. Ryan and Gross' study relied on retrospective data, asking farmers to indicate when they recalled first adopting hybrid seed. It's thought that the data were pretty accurate because farmers would know when they first started planting a portion of their crop using hybrid seeds. The other thing that Ryan and Gross eventually discovered too was that farmers, when they first started to adopt hybrid seed corn, did not plant all of their corn acreage in hybrid seeds immediately. They typically marked off a small plot, a portion of their farm acreage, and used it for hybrid seeds the first year to test on their own soil how well the hybrids did compared to their the stored seeds that they had from the previous year. So a farmer, say in 1931 or 32, might plant 20% of his acreage with hybrid seeds and see how it does before deciding to plant more of their acreage the following and subsequent years. So there was a trial period that farmers went through. One of the things that Ryan and Gross were interested in was the contrasting of economic and social variables in the diffusion process. But more importantly, they established the diffusion paradigm that we are still using very much today, specifying many of the variables that are important to investigate. And we are still interested when studying diffusion to try to determine whether or not economic variables are more or less important than social ones. Economic variables being wealth that people have available to buy a new technology, social variables being interpersonal influence, or perhaps messages that people hear via the mass media. Well, the classic text on diffusion of innovations is Everett Rogers' Diffusion of Innovations, first published published in 1962, and subsequent editions published in each of the ensuing decades, the most recent being in 2005. It is a fantastic book that explains very well all of the different factors that are associated with diffusion and adoption that occur across many different applications, including agricultural applications, public health, medicine, sociological, technological, and so on. These are fantastic books, and I encourage you to consult the 2003 edition if you're interested in reading more about this subject. Well, to understand how diffusion occurs, you can do a very simple experiment on your own computer by using an Excel spreadsheet. I created just a simple explanation using an Excel spreadsheet where we start with a hypothetical community of 100 non-adopters or people who are not infected with the disease or whatever. And we're going to assume that there is a conversion rate, the rate at which adopters and non-adopters interact and adopters convert non-adopters, of 1%. And then, for the purposes of this exercise, we will assume that 5 people or 5% of the population starts to use the new idea or product. Or alternatively, if you prefer a disease explanation, 5 people become infected with the flu or some kind of virus. They interact with the 95 who have not yet adopted or are not yet infected and convince them to adopt at a rate of 1%. At the end of that time period, you have 4.75 new adopters. These are people that are new users of the technology, newly infected with the disease, and so on. So that gives us an existing pool now of 9.75 non-adopters. They interact with 9.75 adopters. They interact with the non-adopters, again convince them at a rate of 1%. Now we get 8.8 new adopters, and then they feed into the existing pool of adopters, interacting with non-adopters and creating this contagion and spread. Now we're assuming that the adopters and non-adopters interact randomly. In fact, we call this the homogeneous mixing model. We don't assume any structure other than there's random interactions between the adopters and non-adopters, and we're assuming a constant conversion rate. We could, of course, change those assumptions and make more complicated the diffusion model, but here is the simple homogeneous mixing model. And when you do that and run this process out over 10 periods, what you get is a very nice, clean growth curve, the so-called S-shaped diffusion curve of the cumulative number of adopters. And you can see here that very much approximates the graph that we saw from Ryan and Gross. And in fact, many innovations diffuse through this sort of typical S-shaped curve. Very slow adoption at first, eventually a gradual increase in the number of adopters until we reach a point of critical mass where the sustaining capability of those adopters convincing non-adopters to adopt is ongoing, and the diffusion process accelerates quite rapidly until it tapers off at the end when there are no non-adopters left in the population. And again, you can see the close to normal shaped curve, the incidence curve of the number of new adopters at each time period. Well, one of the classic studies to investigate whether or not that homogeneous mixing model made sense was Coleman, Katz, and Menzel investigation of why physicians adopted tetracycline in the 1950s. Coleman, Katz, and Menzel were able to obtain some funding to look at the diffusion of tetracycline in 4 communities in Illinois. They interviewed all of the physicians in those communities and also inspected the prescription records to determine exactly when each of the physicians adopted tetracycline. And these are curves for the diffusion of tetracycline among these physicians, graphed separately by how connected they were in the network of other physicians. What Coleman, Katz, and Menzel had reasoned was that it's not just communications from the mass media or external forces that influence people's adoption decisions, but that physicians are influenced by other physicians. And if you look at the diffusion curve, for those physicians that have the most connections, you can see it's a much more rapid diffusion than for those physicians who have no communications or few connections to other physicians. And Coleman, Katz, and Menzel concluded from these data that there was a contagion effect of the diffusion of tetracycline among physicians such that it was more rapid among those with more communication partners. These were other physicians that they reported as discussion and advice partners for medical information.